What I'm going to do is I'm going to show you today how to make models to represent various percent solutions. And what you're going to do is we're really going to make some models that look like the ones that are on the back board. Okay, so let's just jump right in. I bet you as soon as you see a couple examples, you're going to totally catch on. So remember on one of our entry slips, we used the example of oxygen in air. Oxygen in air. Remember that oxygen was 20% of the air. And actually, almost all the rest of that is nitrogen. There is 1% of the air that is other sorts of gases, but for our purposes, what we're going to do is we're just going to look at it as 20% and 80%. Okay, so that means for oxygen, 20 out of 100, 0.2 or 20% is the oxygen. For nitrogen, it's 80 out of 100, 0.8 or 80%. Just like that. Okay, so we can look at this two ways. These are the fractions of the whole, but we could also look at it in terms of a ratio. So if you look, for every 20 pieces or 20 molecules of oxygen, there are 80 molecules of nitrogen. If we kind of find some common factors in those, notice we can divide both of these by 5. Then we end up getting 4, and we end up 81 times. We get 16, just like that. Well, look, I can still divide this more. And we end up getting a final ratio. It's a final ratio of 1 to 4. So that means for every 1 oxygen molecule, there will be 4 nitrogen molecules. So from there, what I want to do is I want to make a model to show what air is going to look like using this 1 to 4 ratio right here. So let's think, how might I do that? How might I do that? A 1 to 4 ratio. Well, you know what I'm going to do is I'm going to find a shape that I want to use. I'm going to use that shape. That's going to be my 1. Now I know that for every 1 of those, there needs to be 4 more of the, so let's put here, we'll put the oxygen one right here. That's my oxygen. For every 1 of those, there's going to be 4 nitrogens. So you know what I'll do is I'll get out 4 pieces of the same size, just like that. 4, so now I have 1 oxygen to 4 nitrogen. Well, I'm noticing that I can make these into hexagons. That's what I'm going to do. And so now you can see I still have that 1 to 4 ratio. I still have that 1 to 4 ratio right there, just like that. So now what I want to do is I want to make this model. I want to make a model of what nitrogen and oxygen in air would look like as a solution with a 1 to 4 ratio. So I know that I have that. So what I know also is that I'm going to need to replicate it. So I'm going to get another one. There's another one, just like that. Hey, you know what? I'm going to get another one. Just like that. I'm going to get another one. And I'm going to keep building these up until I have enough to make a larger solution. So notice in all these, I still have a 1 to 4 ratio. 1 to 1, 2, 3, 4. Notice that that 1 to 4 ratio is different as a fraction. I would say that my red is 2/5 of that fraction. 1 out of 1, 2, 3, 4, 5 pieces. But it's a 1 to 4 ratio. So now what I'm going to do is I'm going to get creative here. And I'm going to start interlocking these so that they make a tessellation, so that they make something that repeats itself over and over again. See, I'm going to be creative and turn this way. That looks like it might be kind of cool. Then I'm going to take this model here and I'm going to put it right there, I think. Yeah, now we're cooking. Take this model. Move it over here. This is looking pretty cool. See, I'm going to get more here. I'm going to keep going with this. So I'm going to get my 1 to 4 again. Make it just like that. And now I think I'm going to, let's see, where can I, ooh. I'll hook this guy right in here. 1 to 4 ratio. Let's see. This is looking pretty cool. So there's my 1 to 4 ratio. And you'll see that I can, if I want to, I really can just start separating this back out again to show how this all fits together. Just like that. Then I can put them all back together to show that it still works. I'm still using the 1 to 4 ratio. It's not exactly like the patterns we looked at back there, but it definitely is evenly distributed. It's 1 to 4. Just like that. Pretty cool. So what you're going to do today is you're going to try and mimic this same process. Okay, you are going to try and make these models to represent these solutions using what you know about the ratios and using what you know about percent of the whole and fraction of the whole. I will definitely be around to help you a little bit, so please let me know if you have any questions. Good luck.